Oh hey, this is Hensley Math, and today we're doing shell method.
What is the shell method, you ask? The shell method in calculus is used to calculate the volume of a solid of revolution by summing up the volumes of thin cylindrical shells. This is what it is like. Ever want to figure out how to make a Russian doll? You must use the shell method. Ever wonder about PVC pipes? Shell method, that's what you got to do. It's like the perimeter except shell for 3D.
So basically, what we're doing here with the shell method is we're taking a function, f of x, right here, from a to b, and what we're doing is we're taking this rectangle right here, and we are rotating it around the y-axis many times. And what's happening is we have thousands of mini rectangles there, and we'll just revolve them, and we go from here to the axis of rotation, from the axis to the axis of rotation. And the rectangles always have to be like next to the axis they have to be horizontal with the axis of rotation. And this is an alternative to shell and washer method. And again, it just looks like a Russian doll because there's one inside the other.
Hey everyone, so you're trying to find the volume of a solid of revolution, but the disk method is not working for you because you can't solve for x. Don't panic, use the shell method instead. First things first, we're gonna look at the axis of rotation. Here's the trick, the shell method is parallel. If you're spinning around vertical axis like the y-axis here, you're gonna wanna integrate with respect to x. If you're spinning around the horizontal axis, which would be this way, you would wanna use y. It's the opposite of the disk method, so don't let that trip you up. Step 2, finding the radius and the height. The radius is the distance from your axis to the shell. So in this diagram, this would be your axis when it's rotating this way, and then this is the shell. So it would be this distance. Then finding the height. The height is just the stretch of the shell, so it would be the height of the pillar, depending on which pillar, or just the height. All right, step 3, set up the integral. So what you do for this is the volume is equal to the integral from a to b of 2 pi times the radius times the height, and then dx, of course, never forget the dx. And then the one thing we're missing here is a and b. So that's step 4. Find the limit of the integral of integration. So here, if we look back at our good old handy diagram here, a to b is just the bounds that you were looking at the shell. So it would be when the shell starts and ends. Step 5, solve. Just plug it in and get the answer. We have a little quick check here. If we are rotating the area under y equals x squared from 0 to 2 around the y-axis, we know r equals x and h equals x squared. The integral would look like this. A, b, so 0, 2, and then 2 pi x. X is rx, and which is the radius, and the height, which is hx, is x squared, and of course we have the 2 pi in front, and never forget the dx. And then you just simplify that down a little bit more, and you get 2 pi integral from 0 to 2, x to the third dx. And then you could solve that further if you would like, but that's all we're doing today in Hensley Math.
Oh hey there, thought we were done? Think again. At Hensley Math, we're never done.
At Hensley Math, we're never done.
We're doing an example problem today. All right, first things first, what's the equation for the example problem? the function here, y equals negative x squared plus 6x minus 5. You can see it's going to make this shaded region under the bounds from 1 to 5 here. So, what do we know when using the shell method? First thing we got to do, we got to find the height. The height is going to be the y. We're going to go from here to here. So, the y is just going to be the x value, or the y value at any point is going to be negative x squared plus 6x minus 5. And that means that the x value for the radius is just going to be x, because we're just going from any point along the x-axis right here, looking for the value. So what are we going to do right now? We're going to set up the integral to find the volume using the shell method. So first thing we're going to do, we're going to go v equals the integral from our bounds of 1 to 5. We're going to go the general equation, which is 2 pi times the height times the radius dx. Never forget that dx. All right, now we're just going to plug it all in. V of x, integral from 5 to 1 equals, no equal sign there, 2 pi negative x squared, I'm just plugging in hx from up here, plus 6x minus 5 times our radius, which is x, dx.